Hello everyone. Today let's solve a problem from Singapore Math Olympiad of senior section and round 2. So this contest is usually a difficult collection of problems in mathematics, and we are going to solve a geometry problem. Let's state the problem first. You have a square ABCD and you have a point which is randomly chosen on the segment CD, which is the point E, and then you draw the triangle AEB and you draw perpendiculars from A and B onto the sides AE and BE. And let the foot of perpendiculars be F and G. You join DF and CG to intersect at some other point H. Now you are going to prove that angle AHB is 90 degrees. So this involves some ideas as prerequisite. If you are familiar with cyclic quadrilaterals and some applications of it, it will help you understand through the solution. Here is the question that we are going to discuss today. ABCD is a square and E is the point on the side. So let me paste the diagram. So shown here is the diagram, and the ABCD square is in orange color. And we have the point F and point G as the feet of altitudes. So we have joined DF and CG to meet at H. Our final question asks us to prove angle AHB is 90. So first, let's prove something that is not trivial and might have a digression from the main course, but let's see what can be done from there. I will give you the motivation of it later. So if you construct the circumcircle of triangle AFB, we know that it passes through the point G because both the angles AFB and AGB are 90 degrees. Alright, what about the point of intersection of the diagonals? Let's call it O, which is also termed as center of the square. We know that AOB is 90, hence all the points A, F, O, G, B are concyclic. This is because angle AFB equal to angle AOB equal to angle AGB equal to 90 degrees. So we know all angles which are equal will lie on a circle, and over here, since that angle is 90 degrees, the chord AB would be the diameter of the circle. So let's have that diagram now. So here is that diagram. And as you could see, the point O, which is the intersection of diagonals or the center of the square, lie on this beautiful circle. Now notice that it would suffice to prove that point H lies on this circle that we just defined, because opposite angles subtended by a chord will add up to 180 degrees. So angle subtended by AB in the upper half of the plane would be 90. So in the lower half, it has to be the supplement of it, which is also 90. So hence, it would suffice to prove that the point H lies on this circle defined by the points A, F, O, G and B, as we have proved that they are concyclic. Alright, let's try to prove this. So this is our new prove that statement, sort of. So if you take a closer look in this diagram, you can notice that the chord AO, which is chord of the blue circle, makes an angle at the circumference which can be determined. Because point B is on the circumference as well. So angle ABO, as we know, is 45 degrees, which can also be pursued as the angle subtended by the chord AO on the circle shown, the blue circle. So since it subtends 45 degree, it should subtend the supplement of it, which is 135 degree on the opposite arc. So angle ABO equal to 45 degree shall imply angle AFO equals 135 degrees. Alright, if AFO is 135, the supplement of that would be EFO. So angle EFO would be 180 minus 135, which is 45 degrees. So this is a very important result. So I will erase this angle because I don't want to make it too messy here. So this would be (45 degrees). Alright, EFO is 45. What else is 45? That could generate some cyclic quadrilateral. Let's join D and O. Let me use orange color to join D and O. What is angle EDO? We know this. What is angle EDO? As BD is the diagonal and point O lies on the diagonal, along with the fact that diagonal bisects the angle at D, which is 90 by 2, angle EDO would be 45 degrees as well. So we have obtained some beautiful conclusion. Angle EFO equal to 45 and angle EDO equal to 45 go in concert with each other to conclude that the points DEOF are concyclic. So angle EFO, angle EDO are both equal, which does imply that points E, O, F, D are concyclic. This is just a fact by the inscribed angle theorem. Alright, so thus we have proved that the points EFO or EOFD are concyclic. So let's erase the diagram that we just drew. And in the similar way, by operating to the right of the square, you would get that points C, E, O, G are concyclic. So let me draw that circle as well. So it will go something like this. Though we can't draw the full circle, it will look like this. So what are the cyclic quadrilaterals? Let me mention it again. It is EOFD and EOGC are cyclic. So after obtaining this result, you will now be amazed by the relation that we are going to establish between the points O, F, H, G. So construct the line segment EO and FO. And let's call angle DEO as theta. Since DEO is theta, we get DFO as 180 minus theta, as they are on opposite arcs. So if that is 180 minus theta, one can conclude that OFH is theta because DFH are collinear. So thus we get that OFH is theta as well. Now let's erase the 180 minus theta and let's come to the angle CEO. Angle CEO equals 180 minus theta due to the fact that D, E and C are collinear. Now CEO and CGO are supplementary because of the opposite angle property. Hence, we would get that after joining OG, angle CGO is theta. Thus, angle OGH is 180 minus theta. Alright, we have exhausted angle chasing. Now we are going to prove a beautiful result that is nothing but angles OFH and OGH are supplementary. Thus, OG, H and F are concyclic. And thus, the point H lies on the blue circle. So that's it. It's that simple. So what was our angle chase? Let me write out that. We assumed that angle DEO is theta, which implied that angle DFO is 180 minus theta. And if I take the supplementary of that, I would get OFH. Angle OFH to be theta. Then we considered angle CEO, which will be 180 minus theta. And by the cyclic quadrilateral EOGC, we would get angle OGC to be theta. So OGH to be angle OGH to be 180 minus theta. So thus we conclude that OFH plus OGH is 180 degrees. And since they are on the opposite side of the line segment OH, they are supplementary, imply by the inscribed angle theorem that the points OGHF are concyclic. But we already know for the fact that the circumcircle of the triangle OGF will be the blue circle, will be this dotted circle that we drew at the start of the question. Hence, the point H must lie on this dotted blue circle, and this blue circle is nothing but locus of all points that subtend 90 degree with the segment AB. Hence, AHB will also be 90 because AB is the diameter, right? So we conclude that angle AHB is 90 degrees. So let me show you the final diagram. So this is how it looks like. Only considering the points on blue circle without the center of square, it would look like this. And since H lies on this circle with AB as the diameter, AHB is 90 degrees. So many students would now ask that, how did we even come about defining the center? And even if one defines the center and prove it to be on the circle, how should we answer the question of motivation behind that? So the motivation is not clear, but I will tell you the way in which I solved it. For example, I found that point O lies on the blue circle, but even I do not know whether it is going to help in the solution or not, because I was unable to figure out the cyclic quadrilateral OFDE. So what I did was, I inverted the entire image about O just because I did not get any other way to proceed. So after the inversion, it looked that the points F star, D and D star and E star are collinear. So I inverted about the circle with radius OA. So then that sort of informed me to think about the concyclicity of the points F, D, E, O in the actual diagram. So this was the way in which I tackled this problem. And you can come up with your own motivation. There could be many other ways in which you can figure out this. I hope you enjoyed this video. So we will learn a lot in the upcoming videos. Happy learning, everyone. Bye.